Hi, I'm Adolph Oliver, and this is a video clip that talks about how an augmented matrix can be used to solve a system of equations. Now, there are a number of different matrix methods, and we're only going to introduce you to this augmented matrix here at the moment. And we're only going to give you 2x2 examples just to show you how it works. The matrix methods really earn their keep when you have 3x3s and especially 4x4s and higher. Anyway, this augmented matrix is also known as Gaussian elimination after the great 19th century German mathematician Carl Friedrich Gauss, who developed the method. What it is basically a shorthand for the elimination method that you learned earlier. The time savings is in not having to write down the variables, but instead just to work with their coefficients. So let's show you how we can translate something like this. Let's say that you've got a couple of equations. Here's the first one, like minus 2x plus 3y equals 12, and let's say x minus 4y equals 3, for instance. Okay. Now, what we're going to do, notice we got this in standard form. Here are the x's, here are the y's, all lined up on top of each other. And the way this is normally written, there are different ways that folks do this. But we just grab the coefficients and forget the variables. So minus 2 and plus 3. Now, I don't have to write the plus. You could if you want. And then where the equal sign goes is where they put dashed lines going down, and then what's on the other side of the equal sign goes over on the right here. Okay, this guy down here, notice the coefficient of the x should be plus 1, so I could write that as 1, the y is minus 4, and the other side is 3. And then we close it off with another square guy like this. So this is how we're going to work with our augmented matrix in this form here. And remember now, you can translate this back because, of course, the first column here is the x's. The second column here are the y's. Okay. And, of course, this is where the equal sign goes. So if you saw this, you'd say, well, this is just minus 2x plus 3y equals 12. Exactly what we have here. So you can translate these back and forth. Now, why are we doing this? Well, let's lead you along a little further here. The method is going to make use of some operations, which are things that we've done before with equations, but they're going to be tailored, of course, to working with the augmented matrix. One of the things is interchanging the rows. Whenever we've solved equations, we could take the second guy first and the first guy second. You know, whoever we take first doesn't matter. So that's interchanging the rows. We can do that here with the augmented matrix. Now, another thing we've done to solve equations, we've cleared out fractions, decimals, things like that. Remember, what we do is figure out, for instance, what the LCD was, if it was fractions we're clearing out, and multiply the whole row by that particular LCD. Now, you can multiply or divide as long as you hit each and every term once and only once, and that's the same thing we can do with the rows up here in the augmented matrix. Now, we'll see examples of these as we go on further here. Now, here's the one down here that matches the elimination method that we've talked about before. Remember, when we're doing elimination, we take a row and multiply it by some number so that when we add it to the other row, the variables disappear. Well, that's exactly what we're up to here. Multiply a row by a number, and you have to multiply each and every term all the way through, and then add it to another row. So this is basically the elimination process. Okay, well, these are known as row operations because they're done in the whole row. Remember, each row represents an equation, so, you know, we've got to treat everybody the same. So, now, the question is, where are we going with this? Well, let me just mention it for the moment, and then we'll see it in some examples that we're going to look at here real quick. The goal is to get the matrix in what is known as triangular form. Okay, this guy up here, we want to do row operations on him, so we end up with something that looks like this. We have a 1 in the first position, a 0 underneath. For the next column, any number here, I'll just put a dot for that, but a 1 here in the diagonal. Here's the dashes coming down, and any number that we end up with here. Okay, notice this forms a triangular form here. That's where they call it triangular form on this. And we'll see how, once we take our original augmented matrix, do row operations on it, and get it in this form, how we can then quickly get the answer to the equation from that. Okay, here's our first example we're going to use the augmented matrix form on. Now we could solve this by lots of other methods too, but we're going to use it as a demonstration of the augmented matrix. Now the first thing is we've got to line up the x's and y's in standard form. It's not uncommon that you get everything all mixed up like this. So for instance, here in this first equation, I've got plus 7x. Okay, so I'll have plus 7x. I want the x's first, and I want the y's. So this negative 8y, if I jump it over to the left side, it'll become positive 8y. And then this 16, negative 16 it is. We got to jump it over to the right. Becomes positive 16. Now let's double check that we did this right. The 7x was on the left, so we left it there. The negative 8y we had to jump over, became positive 8y. The negative 16 had to go on the right. That's where the plain numbers are, and so it went to positive 16. Okay, now the second guy we got to clean up also. Okay, so what do we have? Negative x, it's got to go on the left. So it'll be positive 1x. You could put a plus 1 if you want, or just write x. Okay. The 4y has to go on the left. So it's plus 4y. It'll go over as minus 4y. Okay. And then the plain number stays on the right. It's already there. So that's going to equal 28. Now, let's double check this again. Biggest thing you have trouble with here is getting signs and numbers goofed up here, but signs are a big thing you got to watch. So the minus x went over the left is plus x. Okay, the 4 plus 4y went over the left is negative 4y, and the 28 was already on the right side where we wanted it. So okay, here we are. Now notice we got the x's on top of each other, we got the y's on top of each other, and here are the plain numbers on the right. So we've got this all cleaned up. Now we can start our solution. Okay, the first thing we're going to do is we're going to write this in the augmented form. So here it goes. I'll do it over here. Here, our square bracket. Now notice we got 7x, you could put a plus in front if you wanted, but just write it as 7, plus 8y, the same idea there, and then here's my dashed line, and we've got 16 over here on the right. Now, we got to do the second guy. This is a plus 1x, okay, we've got minus 4 for the y, and then we've got 28. Okay, now let's double check that we got this right. Plus 7x plus 8y equals 16. This would be plus x minus 4y equals 28. Looks good. Okay, now remember again, our goal over here, let's see, I got a little bit of room right here and I'll put it down. We want, of course, triangular form because it's going to allow us to get our final answer well. And this triangular form is going to look like this again. We want a 1 in the top left, a 0 underneath it. a 1 on the diagonal coming down, and then the rest of the guys are whatever numbers show up that will give us the answers to our equations. So remember again, this is the triangular form. So what we want to do is start working on this guy to get him in this shape. Well, here's the first thing you look for. You want a 1 in the top left. Notice we got a 1 down here. There's a little gift we got. And we can interchange the rows. So what I'm going to do here is write this second guy first. Now, once you get working with this, you probably would have done this right at the beginning here. But here it is, 1 minus 4 and 28. I made it the top guy. And then the other one here, 7 and 8. Okay. And 16. Okay, here we are. So, what we have up here is a start on our triangular form. We got a nice +1. Now, here's the beauty of this and what allows computers to be used to program it. We want to zero this guy. And it's always easy to tell what we have to multiply this first row by and then add it to this. It's just the opposite of this guy once you got a 1 up here. So here's what we're going to do. We're going to take this whole first row and multiply it by -7 and add it to the second row, and this will get us along a little bit further. Now, let's go down here again and show our next renditions. Now remember, for us humans, this is pretty slow because we got to rewrite this all the time. Computers are just changing the numbers in memory, so they do this very quickly. Anyway, here's the first thing. We don't want to change this first row up here because we got that 1 that we want in our leading position. And I'll circle it again just to emphasize that that's what we want. Okay, and let's see what we have here, 28. Okay. Now, the second guy. We're going to take every member in the first row, multiply it by -7, and add it to the second. Notice what happens in our first case. -7 times 1 is -7. -7 plus 7, 0. So that's how you get that 0 that we want. Now, you got to preserve the balance here and multiply correctly all the way across. So, -7 times -4 is going to give me +28. +28 plus this 8 is going to be 36. Okay. Now, we're still going. We got to take -7 times 28 over here. Now, I'm going to go off on the side and multiply this out. 28 times 7, I'll know it's negative here. 7 times 8 is 56. 2 times 7 is 14, and 5 is 19, so 196. So what we had here was -196 once we took -7 times 28, and then we combine it with this plus 16, so it's going to be negative what? I think 180 minus 180. There we go. Okay, well, we're getting real close. The only thing left to do down here is change this guy to a 1, and anytime you want to make 1s in a diagonal, you just divide by what's there. So we're going to divide by 36. Now again, we got to do it to every element going all the way across here. So let's carefully keep track of what we're doing. Now once again, we don't want to change the first row. Remember, we got that 1 up there we want, so there it is. I'm just going to rewrite the first row down. Here it is, okay. And then, notice this. I've got to take the 0 and divide it by 36, but what's 0 divided by 36? Still 0. This is what makes this work good. We don't destroy that 0. Now, 36 divided by 36 is 1. There we go. We got the 1 that we wanted. Now, 36 divided by, divided into -180. I think that goes 5 times, doesn't it? 5 times 36, 150, yeah, I think 5. And notice it's negative. So negative 5, huh? Okay. So here we are. Now, we got this triangular form, okay? Now, here's why it works good. Remember again, these are the x's, these are the y's, and this is where the equal sign goes. So what we have from this guy right immediately is simply this. If we translate it back to an equation, there's 0x, so no x's, plus 1y, so we have y, equals negative 5. Well, look at that. There's our first part of our solution. Y equals negative 5. Now, to get the x, go back up and translate the other equation up here, the top row. So it's 1x, I'm just going to write it out with all the variables to begin with, minus 4y equals 28. Okay. Well, now, of course, we're solving for x, so this will be x minus 4 times, and the y we got to be negative 5, huh? Okay. So here's the equation. I just simply plugged in for y what we got for y, minus 5. So this is x plus 20 equals 28. Take the plus 20, jump it over as negative 20. Okay, and it looks to me like what we have here is x equals what? 8, huh? So there we go. Well, this is our system solution here for this. Okay, system solution. The x equals 8 and the y equals negative 5. Now, if you took those values and plugged them back up into our original equations up here, they'd balance it out because they're the solutions of this. Okay, here's another 2x2 system that we're going to use to demonstrate augmented matrices again. And notice, of course, we've got some fractions here. So the first thing I want to do is clean these guys up, and then we'll have to put them in standard form. So the LCD here is 4, in fact, for both of them. So let's just do the first guy up here first. I'm going to multiply each and every term on both sides by 4. So if I do that, I'm going to have, okay, 4y here equals, now notice the 4's reduce out here, so it's going to equal negative 7x, okay, and then we have 4 times 3 plus 12. Now let's double check this. Okay, we're hitting each and every term by the LCD 4. This is just clean up before we're starting the augmented matrices. So I got 4y minus 7x equals 12. Okay, that looks for plus 12, I should say. Now, let's go get the second guy, and it turns out that I have to multiply him by the same thing here. Okay, so here it goes. And so once again, the 4's will cancel out here. So I'm going to end up with y equals, let's see, actually it's going to be 4y, 4 times y. So 4y equals negative 1 times x, so negative x, and then negative 12. Okay. Let's now double check this once again. Okay, this is going to be 4 times y equals, here we go, negative 1 times x, so negative x, minus 3 times 4, negative 12. Okay, so now what we've done is we've cleaned the equations up so that we don't have fractions in them anymore. It's easier to work with the whole numbers. We'll often get fractions in the answer, but putting them off for as long as we can is generally a good idea. Now, of course, we got to put these guys in standard form. So I've got to jump this negative 7x over to the other side. So it's going to become positive 7x. We got positive 4y here already. And this then equals 12. Now let's double check again. Negative 7x goes over as positive 7x. The 4y was on the left. It was positive, so it stays there. The plus 12 was on the right where we wanted it. It stays there. Okay, the second equation. We're going to jump the negative x over, so it becomes positive x. Okay, then we have plus 4y. Here we go. Equals, not equals, let's see. Yeah, the equals, we want this guy on the right side. Okay, that's correct, so it is equals. Remember, standard form, we want the variables on the left, so I move the x over, and here I've got negative 12. Now let's double check this again. The x goes over as positive x, the 4y was on the left, it stays there. Okay, then we have the equal sign, and the minus 12 stays on the right. Okay, looks like we've got these guys finally cleaned up and ready to go for augmented matrix. See, these are the x's, these are the y's, and of course the equals and what they are. So now, let's turn around here and write these guys in augmented matrix form. Here we go. Now, notice this, and this will be a time saver. Remember, in triangular form, we wanted to have 1, 0, 1, and the dots here were whatever numbers they turned out to be. So we wanted to have a 1 in this top left corner. Well, let's just do this second equation first, because he's got a 1 there already, and it'll save us writing this all down one more time. So I'll write the second equation first. Remember, we can interchange the rows, which is interchanging the equations. So I'm going to have a 1. Okay, I'm going to have plus 4. Here comes the dashes for the equal sign. And then we got negative 12. Okay, here's the other square bracket. Now, this guy up here then becomes my second equation. Okay, I got 7 and 4 and positive 12. Okay, now let's double check this again. I moved the second guy up to the first position, so I had 1, 4 equals negative 12. The first guy went down to the second position. We had 7, 4 equals 12. Okay, that looks good. Now, why'd I do that? Well, we got a gift. Not always are you going to get one of these guys having a coefficient of 1 in front, but if you do, just move him up to the top, make him the first player, and there you go. Okay, now, once again, we want to 0 the guy underneath him, so we just multiply the first row by the opposite of this, and that's what'll 0 it. Okay, so here we go. Now, remember, we don't want to change the first row. We got the 1 there that we want. So we're not going to fool with it. We're going to use it, but I'm not going to change it. Okay, so there's the first row again. Now, carefully going across. Negative 7 times 1 is negative 7 plus 7. There's the 0 that we wanted. Okay, negative 7 times 4, that's negative 28, huh? Negative 28 plus 4, I think, is what? Negative 24. Okay. And then, what we have here, negative 7 times 12. Well, let's see, that's 84. So this is negative 84. And then we're adding plus 12 to it. Remember, we always multiply the top row by this and then add it to this guy. So negative 7 times negative 12 is negative 84. Now add 12 to it. I think we got, what, 72? So negative 72. Okay, well, we're only one step away to having our triangular form that we want. we got to change this negative 24 to a 1. And remember, whenever you want to change somebody to a 1, you simply divide by what that value is. So here we go. Let's rewrite this again. Okay. Now, again, we're not going to change the top row. We want that the way it is. So I write it down. There's the one that we want. And here are the other numbers that come out in it. Okay. And now, let's see. We're going to multiply everybody. Not multiply. We're dividing by negative 24 because we want to turn this into a 1. Anytime you want to change somebody to 1, you just divide by what they are, and that works good. Now remember, we don't destroy our 0. What's 0 divided by negative 24? Just 0. So that's the beauty of it. We don't destroy that. Now, negative 24 divided by negative 24 is 1. So there's the other 1 we want. Negative 72 divided by negative 24, I think just turns out to be 3, isn't it? 2 negatives give a positive, so yeah, there we are. Okay, well now, once we got this triangular form again, there it is. Okay, now we're all set to get our answers. The first guy here, remember, this is the x's again, this is the y's, okay, on this. So now we just write this as no x's, 1y equals 3, or simply y equals 3. So there's one of our solutions. Now, take the other equation on top and write it out. We've got 1x, okay, plus 4y, I'm just going to retranslate it and then we'll substitute, equals negative 12. Okay, y equals 3, we got that earlier, so x plus 4 times the 3 equals negative 12. Okay, well, this is, we keep going on it here, looks to me like it's x plus 4 times 3 is 12, huh? Okay, and equals negative 12. Now, of course, what we have to do here is we want to solve for x, so the plus 12 has to go over as negative 12. So, kind of looks to me like we end up with x equal to what? Negative 24. Okay, so there's the x value, x equals negative 24. So, our system solution here, okay, when we put this back together, okay, is x equals negative 24 and y equals 3. Okay, here's the last example we're going to look at, and like the others, we got to clean up things a little bit. We want to get it in standard form. So this first equation, we've got negative 9x on the left. That is a negative, yes. And then we got plus 7y. We want to jump that over, so that becomes negative 7y. And then that equals, on the right, 28. Now let's again double check that we got this right. The negative 9x was on the left, so we left it there. The plus 7y had to jump over. It became negative 7y, and that equals 28. All right, that one looks good. Now, this guy right here, we got the x and y on the left, but they're out of order. So I'll write this negative 9x minus 7y equals, and what do we have here for a number? Looks like 49. Now let's double check this. Both the variables were on the left. I just put the x first, negative 9x, then minus 7y equals 49. Okay, next thing to do then, of course, is to put these guys into the augmented matrix form. So let's do that. Notice I don't have somebody being a nice 1 here that I can shift up the top, so we'll have to clean this up ourselves. So let's see, I've got negative 9 minus 7, and my dashes here equals 28 over here. Close it off with the square guy on this side. Then I've got negative 9 minus 7 equals 49. Okay, now what I want to do is change this first guy up here to 1. So what I'm simply going to do is divide him by negative 9. Remember, you ever want to change somebody to 1, you divide them by what you see. So this first row up here, let's rewrite it here. Okay, negative 9 divided by negative 9 is 1. There's that 1 we wanted. Now, negative and negative is positive, and 7 divided by 9 is 7/9. Not uncommon that you get fractions in these guys. And then over here on the right, 28 divided by negative 9 well, it's going to be negative. And 28 divided by 9 I can write as a fraction like this. There we go. Now, the second guy, of course, we weren't changing at the moment, so I just write him back down exactly like he is. Here he goes. And we got 49 over here. Okay, now we want to zero this negative 9. Well, we know what to do. Turn around and just multiply the top guy with the 1 up here by the opposite of this, which is plus 9. So, let's write it right here where we got some more room to be able to do it. Now remember, we're not going to change the top row because we got the one that we wanted there. So we got 7/9, and over here we got negative 28/9. Okay. Now, here we go. We're multiplying 1 times plus 9 gives me plus 9. Combine it with negative 9. Well, that's how we get that 0 we want. That's why we did it. Now, let's go over here. Plus 9 times 7/9. Well, the 9's cancel out, so this is plus 7. Plus 7 minus 7. Oh, look what just happened. We got a 0 here. Well, we can stop right at this point because there's no way we can turn this guy into a 1. We can't divide 0 by 0. That's undefined. So what just happened here is we lost our variable y. Well, what that means is, okay, the y variable, okay, is gone. Okay, and remember, in systems of equations, when you lose variables like this, what that means is you've got a bad solution. Okay? In other words, there's no xy that solves this. What happens is these guys are either parallel to each other or on top of each other. Well, you might have noticed that back at the beginning up here. I didn't say anything, but you might have seen it. Remember up here when we clean these guys up? Negative x minus 7y, negative 9x minus... These are exactly the same. Okay, but they've got different numbers over on the right, so that means since the variables match here, you know, you can multiply this guy by 1, get this, multiply this guy by 1 and get this. That means the slopes are the same. And when you have the slopes the same, you got one of the bad cases. Now, since the numbers on the right are different, that means the y-intercepts are different. In other words, these are not the same equation. For this to be the same equation, this would have to be a 28 here. So, you can go back and look at this and say, okay, this is the old parallel line case, okay, where the lines don't cross, so officially there's no solution. But Down here, that's how you see it, and we've had other solution methods that have indicated the same thing. As we're going along and doing the proper stuff, if the variables disappear, and it did here, then that means we got a bad solution. We can go back up and take a look and see that yes, indeed, that's the case.